The history, current status, challenges, and future development of satellite internet services, an analysis of technology, market, and applications. Historical context. The journey of satellite internet services began in the mid-20th century, marking a pivotal shift in global communications. The first artificial satellite Sputnik 1, launched by the Soviet Union in 1957, initiated a new era of space exploration and communication. The following decade saw the development of early communications satellites such as Telstar in 1962, which enabled transatlantic television broadcasts and telecommunications. Over the years, satellite technology evolved significantly, particularly with the introduction of digital processing in the late 20th century. This transformation turned satellites into sophisticated digital processors capable of handling high volumes of data and enabling various communication services. The advancements followed a trend similar to Moore's law, which predicts that computing power will double approximately every 18 months, resulting in improved performance and capabilities for satellite communications. By the late 1990s and early 2000s, the first commercial satellite internet services began to emerge, providing connectivity to rural and underserved areas. Companies like HughesNet and WildBlue, later acquired by Viasat, expanded the availability of satellite internet, though they were often hampered by high latency and bandwidth limitations typical of geostationary orbit (GEO) satellites. The advent of low Earth orbit (LEO) satellites has since revolutionized the landscape, leading to the development of megaconstellations aimed at providing global internet coverage. SpaceX's Starlink, launched in 2019, marked a significant milestone in this new era, deploying thousands of LEO satellites to enhance connectivity and reduce latency. Current status. Today, satellite internet services are more competitive and accessible than ever before. Major players in the market, including SpaceX's Starlink, Amazon's Project Kuiper, OneWeb, and others, are actively deploying satellite constellations to expand broadband access globally. This competitive environment has driven advancements in technology, resulting in higher speeds and reduced latency compared to traditional GEO satellite services. Starlink, for instance, has gained substantial traction, offering internet speeds ranging from 50 megabits per second to 150 megabits per second, with latency between 20 milliseconds to 40 milliseconds, making it a viable alternative to terrestrial broadband in many regions. Other companies are following suit with plans to launch their constellations and compete for market share. The demand for satellite internet services is growing, particularly in underserved and remote areas where traditional broadband infrastructure is lacking. Industries such as agriculture, telemedicine, education, and emergency response are increasingly reliant on satellite connectivity to operate effectively. The COVID-19 pandemic further highlighted the necessity for reliable internet access, accelerating the adoption of satellite internet services in various sectors. Key challenges. Despite the promising advancements in satellite internet technology, several challenges persist. 1. Orbital debris. The increasing number of satellites in orbit raises significant concerns about space debris. Collisions between satellites or between satellites and debris can result in catastrophic failures and further exacerbate the debris problem. Organizations like the European Space Agency (ESA) are actively researching mitigation strategies to address this issue. 2. Regulatory hurdles. Navigating the complex landscape of international regulations and frequency allocations is a significant challenge for satellite internet providers. Each country has its regulatory framework, and coordinating between different jurisdictions can delay deployments and create operational hurdles. 3. Infrastructure costs. Building and maintaining the necessary ground infrastructure to support satellite communications can be prohibitively expensive. The costs associated with launching satellites, establishing ground stations, and providing customer equipment can deter new entrants to the market. 4. Technological limitations. While LEO satellites offer improved latency and speed, challenges remain. For instance, latency can still be an issue for applications requiring real-time communication such as online gaming or video conferencing. Additionally, bandwidth limitations can hinder performance during peak usage times. 5. Market competition. The competitive landscape is rapidly evolving with both established companies and new entrants vying for market share. This competition can lead to price wars affecting profitability and long-term sustainability for providers. Future development. The future of satellite internet services is expected to be marked by continued growth and innovation. Several key trends and developments are anticipated. 1. Enhanced processing capabilities. Ongoing advancements in satellite technologies will lead to more powerful processors and improved encoding techniques. These innovations will enable higher data rates, more efficient communications, and enhanced user experiences. 2. Integration with terrestrial networks. A convergence between satellite and terrestrial communications is expected, facilitating seamless connectivity across different platforms. This integration will benefit users by providing more reliable and flexible service options. 3. Emerging markets. Global economic growth and increasing interconnectivity will drive demand for satellite internet services in developing regions. Countries with limited broadband access will increasingly turn to satellite solutions to support education, healthcare, and e-commerce initiatives. For sustainability initiatives, the industry is likely to place greater emphasis on sustainability, focusing on responsible satellite end-of-life strategies and minimizing space debris. Initiatives may include deorbiting satellites at the end of their operational life and developing technologies to actively remove debris. 5. Technological innovations. Advancements in technologies such as artificial intelligence, AI, machine learning, and advanced materials will enhance satellite capabilities. AI can optimize satellite operations and decision-making processes, improving overall performance and efficiency. 6. Global collaboration. Collaborative efforts among governments, private companies, and international organizations will be essential for addressing challenges such as orbital debris, regulatory frameworks, and infrastructure development. Partnerships can facilitate knowledge sharing, resource pooling, and joint initiatives. Conclusion. The satellite internet sector is at a pivotal juncture, navigating a landscape characterized by rapid technological advancements, evolving market demands, and pressing challenges. As the industry continues to grow, stakeholders must adapt to the changing dynamics, focusing on innovation, sustainability, and collaboration. The integration of advanced technologies and strategic partnerships will be crucial for realizing the full potential of satellite internet services. By addressing the challenges of regulation, infrastructure, and sustainability, the sector can ensure its continued growth and play a vital role in bridging the global digital divide. The future of satellite internet services promises to be dynamic and transformative, with the potential to enhance connectivity and improve lives worldwide. Counterintuitive information in satellite internet services. 1. Technological advancements versus consumer awareness. While satellite technologies have seen immense improvements over the last few decades, the general public's perception of these advancements often lags behind. This contrasts with the rapid pace of innovation in other industries, resulting in consumers underestimating the capabilities of modern satellite internet services. 2. Cost of infrastructure versus market demand. Although the initial costs of building ground infrastructure for satellite internet can be exorbitant, the high demand for global internet connectivity, especially in underserved regions, can lead to significant long-term profitability. This suggests that high upfront costs do not necessarily deter market entry, rather they may be a stepping stone to lucrative opportunities in emerging markets. 3. Latency misconceptions. Many users assume that satellite internet inherently suffers from high latency due to the distance signals must travel. However, advancements in low Earth orbit (LEO) satellite constellations are significantly reducing latency levels, making satellite internet comparable to some terrestrial broadband services. This challenges the common belief that satellite internet is always slow and unreliable. For orbital debris versus satellite launches, the increase in satellite launches is often seen as a positive trend for expanding internet access, yet it paradoxically contributes to the growing issue of orbital debris. This creates a potential long-term challenge that could impede future satellite deployments, contradicting the notion that more satellites will always lead to better connectivity. 5. Convergence of technologies. The expectation that satellite internet will remain a separate entity from terrestrial networks is misleading. The future indicates a convergence where satellite and terrestrial systems will work together to provide seamless connectivity. This challenges the traditional view of satellite internet as a niche service, emphasizing its role in a broader communication ecosystem. 6. Regulatory complexity as an opportunity. While navigating international regulations and frequency allocations is often viewed as a barrier to entry for new satellite internet service providers, these complexities can also present opportunities for innovative companies to carve out niche markets or develop unique solutions that comply with regulations while meeting consumer needs. 7. Sustainability initiatives as market drivers. The push for sustainability in satellite operations may be perceived as a mere regulatory compliance effort. However, companies adopting proactive sustainability measures, such as responsible end-of-life strategies for satellites, can differentiate themselves in the market, attracting environmentally conscious consumers and investors. 8. Emerging markets as growth engines. The misconception that satellite internet is primarily for remote or rural areas overlooks the potential of its applications in urban settings, such as disaster recovery and emergency communication. This presents a counterintuitive perspective where the growth of satellite services is not limited to underserved areas but can significantly impact urban environments as well. 9. Integration with defense needs. While satellite internet services are primarily marketed for civilian use, there is a significant overlap with defense applications that could drive technological advancements in funding. This dual-use nature can be counterintuitive as commercial and military interests often intertwine, influencing the development and deployment of satellite technologies. 10. Market saturation versus growth potential. Although the market appears competitive and potentially saturated with multiple players, the continuous demand for enhanced connectivity and the emergence of new applications, such as IoT and smart cities, indicate that substantial growth potential remains. This challenges the perception that the satellite internet market is reaching its limits. These counterintuitive insights highlight the complex and evolving nature of satellite internet services, emphasizing that assumptions about technology market dynamics and consumer behavior may not always align with reality. As the industry continues to develop, understanding these nuances will be crucial for stakeholders aiming to navigate the landscape effectively. The report on the history, current status, challenges, and future development of satellite internet services encapsulates a broad spectrum of critical insights, many of which may be overlooked by a casual reader. Here are several key points that deserve particular attention. 1. Historical breakthroughs in digital transformation. The transition from analog to digital satellite communication has been a pivotal moment in the evolution of satellite internet services. While many may recognize the current capabilities of satellite technology, the significance of digital processing cannot be overstated. Early satellites were limited in their functionality, but the integration of digital technologies transformed them into advanced processors capable of handling complex data. This shift not only enhanced communication efficiency but also laid the groundwork for future innovations. The historical context highlights how advancements in satellite technology have been influenced by Moore's law, which posits that processing power doubles approximately every 18 months. The ongoing relevance of this law emphasizes that satellite technologies are not static, they continue to evolve rapidly, which is crucial for stakeholders to understand as they invest or engage in this sector. 2. Current market dynamics and competition. The current landscape of satellite internet services is characterized by significant competition, particularly with the emergence of megaconstellations like SpaceX's Starlink and Amazon's Project Kuiper. While many may focus on the technology itself, The competitive dynamics and market strategies of these players are essential for understanding the landscape. The entry of new players into the market can lead to price reductions and improved services, but it also raises concerns about sustainability and the long-term viability of different service providers. Recognizing the market trends can inform potential investors and policymakers about where the industry is heading and what strategies may be effective in navigating this evolving marketplace. 3. Orbital debris and environmental concerns. One significant challenge that often receives less attention is the issue of orbital debris. As more satellites are launched into space, the risk of collisions increases, which can create debris that jeopardizes future missions and existing satellites. This is not just a technical challenge, it is an environmental concern that has implications for space policy and regulation. Addressing orbital debris requires coordinated international efforts to establish guidelines and best practices for satellite launches and end-of-life decommissioning. The implications for sustainability in space operations are profound, and stakeholders must prioritize debris mitigation strategies to ensure the continued viability of satellite services. 4. Regulatory hurdles. The complexities of international regulations and frequency allocations can significantly impact the deployment and operation of satellite networks. While the technical aspects of satellite internet services are often highlighted, the regulatory environment deserves equal scrutiny. Regulatory challenges can create barriers for new entrants, stifle innovation, and lead to delays in service rollout. Understanding the regulatory landscape is critical for companies looking to enter the satellite internet space, as well as for policymakers who aim to foster a competitive and innovative environment. 5. Technological limitations. Despite advancements, the issue of latency and bandwidth limitations remains a crucial challenge. Many may overlook the fact that while LEO satellites promise reduced latency compared to traditional geostationary satellites, they are not a panacea for all application needs. Applications requiring real-time data transmission, such as telemedicine or remote surgery, still face hurdles. Recognizing these limitations is vital for setting realistic expectations about what satellite internet can achieve and for identifying areas where further research and development are necessary. 6. Future trends and sustainability. The anticipated trends in satellite internet services, such as enhanced processing capabilities and integration with terrestrial networks, highlight the potential for a more interconnected and efficient communication landscape. However, the emphasis on sustainability initiatives is particularly noteworthy. As the industry grows, the need for responsible practices regarding satellite end-of-life and minimizing orbital debris will become increasingly critical. Stakeholders must proactively address these issues to ensure that the expansion of satellite internet services does not come at the expense of the space environment. Conclusion. The report underscores that satellite internet services are at a pivotal moment with significant opportunities and challenges ahead. By focusing on the historical context, competitive dynamics, regulatory frameworks, and sustainability initiatives, stakeholders can gain a deeper understanding of the complexities involved in this rapidly evolving field. Recognizing these often overlooked aspects is essential for making informed decisions that will shape the future of satellite internet services. As technology continues to advance and the market becomes more competitive, a holistic understanding of these elements will be crucial for success in the satellite communications industry. 1. Technological evolution and processing power. The historical context of satellite internet services highlights the significant advancements in technology over the past few decades, particularly the shift towards digital processing in satellites. This evolution has led to the development of satellites that function as powerful digital processors, enabling enhanced communication capabilities. The continuous adherence to Moore's law, which predicts the doubling of processing power approximately every 18 months, suggests that future advancements will further enhance performance, data rates, and efficiency in satellite communications. 2. Market dynamics and megaconstellations. The current status of satellite internet services is characterized by a competitive landscape with major players like SpaceX's Starlink and Amazon's Project Kuiper deploying thousands of low Earth orbit LEO satellites. This shift to megaconstellation projects aims to provide global coverage and reduce latency, addressing the connectivity needs of underserved and remote areas. The market's evolution reflects increasing demand for reliable internet access driven by technological advancements and changing user needs, as well as the emergence of new entrants seeking to capitalize on these opportunities. 3. Challenges facing the industry. Despite the promising advancements, the satellite internet sector grapples with significant challenges. Key issues include the proliferation of orbital debris, which poses risks to operational satellites, and complex regulatory hurdles associated with international frequency allocations. Furthermore, the high costs of building and maintaining ground infrastructure can be a barrier for new entrants. Additionally, technological limitations such as latency and bandwidth constraints still hinder certain applications, particularly those requiring real-time data transmission. 4. Future trends and sustainability. The future development of satellite internet services is poised for innovation and growth, with anticipated trends including enhanced processing capabilities, integration with terrestrial networks, and a focus on sustainability. As the demand for satellite internet services expands in developing regions driven by needs for education and healthcare, the industry is expected to adopt responsible practices regarding satellite end-of-life strategies and minimizing orbital debris. This emphasis on sustainability alongside technological advancements and market integration will play a crucial role in shaping the future landscape of satellite communications. 1. The launch of Telstar 1. 1962. The Telstar 1 satellite, launched on July 10, 1962, marked the first active communications satellite and ushered in the era of satellite communications. This satellite enabled transatlantic television broadcasts and established the feasibility of satellite-based communication for a variety of applications, including telephony and data transmission. The success of Telstar 1 demonstrated the potential of satellites to provide real-time global communications, laying the groundwork for future satellite systems. 2. Iridium Satellite Constellation 1998. Launched in 1998. The Iridium satellite constellation consisted of 66 low Earth orbit satellites designed for global mobile communications. The project aimed to provide telephone and data services to remote areas and was notable for its ambitious scope. However, it faced significant challenges, including high costs and market competition, leading to the company filing for bankruptcy in 1999. Despite its initial struggles, Iridium was restructured and continues to provide critical communication services, especially in maritime aviation and emergency response sectors. 3. The rise of Globalstar 2000. Globalstar, launched in 2000, was another significant player in the satellite communication industry, focusing on providing mobile voice and data services. The Globalstar system comprised a constellation of low Earth orbit satellites designed to deliver affordable communication services in areas lacking terrestrial infrastructure. Like Iridium, Globalstar faced financial difficulties, leading to a bankruptcy restructuring process in 2002. However, it has since emerged as a key provider in satellite communications, catering to various industries including agriculture, energy, and transportation. These historical cases illustrate the evolution of satellite communications, highlighting both the potential of satellite technology and the challenges that can arise in its implementation and commercialization. Future outlook for satellite internet services. The future of satellite internet services is poised for significant transformation, shaped by technological innovations, evolving market demands, and a growing emphasis on sustainability. Below are key predictions for the next decade and beyond. 1. Expansion of low Earth orbit LEO constellations. The trend of deploying large LEO satellite constellations will continue to dominate the satellite internet landscape. Companies like SpaceX's Starlink and Amazon's Project Kuiper are expected to expand their constellations to achieve global coverage with reduced latency. By 2030, it is anticipated that LEO networks will provide near-universal internet access, particularly in remote and underserved regions. 2. Enhanced data speeds and lower latency. Technological advancements in satellite design and manufacturing will lead to enhanced data speeds and reduced latency. Innovative communication protocols and improved ground station technologies will allow for seamless integration with terrestrial networks. By 2030, users could experience internet speeds comparable to or exceeding those of traditional fiber optic networks, making satellite internet a viable option for high-bandwidth applications. 3. Integration with 5G and next-generation networks. Satellite internet services will increasingly integrate with 5G networks to provide hybrid connectivity solutions. This integration will enable users to switch between satellite and terrestrial connections seamlessly depending on their location and network availability. By 2035, this convergence will facilitate unprecedented levels of connectivity, supporting applications such as smart cities, autonomous vehicles, and the Internet of Things (IoT). 4. Emerging applications and markets. As satellite internet becomes more reliable and accessible, new applications will emerge across various sectors, including agriculture, healthcare, education, and disaster management. For example, remote sensing and precision agriculture will benefit from satellite connectivity, while telemedicine will expand its reach to rural populations. By 2030, these applications could drive substantial economic growth in developing countries. 5. Focus on sustainability and space debris management. The growing concern over space debris will prompt the satellite industry to adopt more sustainable practices. Companies will increasingly prioritize responsible satellite design, end-of-life disposal strategies, and active debris removal technologies. By 2030, regulatory frameworks may mandate these practices, ensuring the long-term viability of satellite operations in crowded orbits. 6. Regulatory evolution and international collaboration. As the satellite internet market expands, regulatory bodies will need to adapt to the new landscape. International collaboration will be essential for establishing harmonized regulations regarding frequency allocations, space traffic management, and orbital debris mitigation. By 2035, a robust international framework could emerge, facilitating cooperation among nations and ensuring the sustainable use of space. 7. Competitive landscape and market consolidation. The satellite internet market will continue to attract new entrants, leading to a competitive landscape characterized by mergers and acquisitions. Established players will seek to consolidate their positions through partnerships and strategic alliances. By 2030, the market could see a few dominant players alongside niche providers focusing on specific applications or regions. 8. Technological innovations in satellite design. Future satellites will incorporate advanced technologies such as artificial intelligence (AI) and machine learning (ML) to optimize network performance and resource allocation. These innovations will enable real-time monitoring and adaptive responses to changing network conditions. By 2035, AI-driven satellite networks could automatically adjust bandwidth and coverage based on user demand and environmental factors. 9. User-centric innovations. As user demand for personalized services grows, satellite internet providers will focus on developing user-centric solutions. This includes customizable service plans, improved customer support, and enhanced user interfaces for satellite communication devices. By 2030, customers may have the ability to tailor their internet experiences based on their specific needs and preferences. Conclusion. The future of satellite internet services is bright, with advancements in technology and a commitment to sustainability driving innovation. As the industry evolves, stakeholders must navigate challenges related to regulation, infrastructure, and competition while embracing opportunities for growth across diverse applications. By 2035, satellite internet could transition from a niche service to a mainstream solution, fundamentally transforming global connectivity and enabling a new era of digital inclusion.